Assalamu alaikum. So in this video we will solve this ordinary differential equation where q is a square wave. Okay, and we will solve this equation and find v with the help of a Python code. That means you don't need to learn any differential equation theory, you just need to know how to write a Python code. Just that's it. So let's start how to solve this equation. So let me increase this thing. So let me give you a practical example. Let's say you have this kind of circuit. And this is a rectangular square wave, and R is equal to 1K and the capacitance is 47 microfarad, and you want to find the voltage across this capacitor V. So let's say the square wave voltage is Vs. That means this node's voltage Vs and this node's voltage is V. So if I want to write the current across this through this capacitor, we know a formula I is equal to C dV by dt, and same current is flowing through the resistor, so Vs minus V divided by R, simple Ohm's law, right? And now if I modify this equation, I will have dV by dt plus 1 by RC. V is equal to Vs divided by RC. Okay, so our equation looks like this, right? This equation is similar to this equation where P is equal to 1 by RC and Q is Vs divided by RC, where Bs is a function of time, as you can see that is a square wave. So in my code what I will do, first R is equal to 1K, C is equal to 47 microfarad, and then I have to choose a small dt. So theoretically dt tends to 0, right? Infinitesimally small number, but in my code I need to take a small number. Let's say what will be the small number. RC is equal to what? RC is equal to 47 into 10 to the power minus 3. It's a small number, so I want to take dt is equal to RC divided by 1000. Okay, so it's a small number. And then I have to choose the initial condition. So it is normal that the capacitor might have some initial condition, initially charge that will create some voltage. So our initial condition will be when time t is equal to 0. Let's say capacitor's voltage is 1 volt. Okay, not 1 volt, that's the 0 volt. So it's the initial condition. And now inside a for loop I have to write dV. So what will be dV? We will have dV from this equation. So let's find dV. So if I take this 1 by RC V to the right hand side, I will have Vs 1 by RC Vs minus V is equal to dV by dt. And now if I take this dt to the right hand side, I will have equation like this. So I will write the same equation here. That means 1 by RC Vs minus V dt. So what is V? What is dV? dV is a small change in voltage, right? That means initially the voltage was V, the capacitor's voltage, and now the voltage has been changed by dV. So the new voltage is V plus dV, and we have to put this new voltage at the same variable B. So what will happen, we will check this inside our code. And one more thing, that we haven't defined Vs. What is Vs? Vs is a square wave, right? So we need to make a Vs. Let's say we want to make a Vs inside a function. Okay, so let's say it's a square wave function. we have to make a square wave function, and we will see inside the code how we have to make the square wave function. Okay, so let's dive into our code. We may need numpy, so let's import numpy. Import numpy as np. So first I need to write r is equal to 1k, then c is equal to 47 microfarad, then rc is equal to r times c, and then I have to write dt is a small number, so rc divided by 1000. And initial condition, when time was 0, let's say capacitor's voltage was 0. Okay, and now I have to run a for loop here. So for t in, okay, so I need to make a time array. So time is equal to np dot arrange. Let's say I want to start the time from 0 to 20 rc. And what is the time interval? Time interval will be dt. So this line will make an array. This line will make an array, and the array will be looks like 0, then 0 plus dt, then 0 plus 2 dt, and this will goes on up to 20 times rc. Okay, so time is an array, then this looks like this. So for t in time, I need to make the equation of dv. So let's make the equation here. Sorry. Okay, so dv is equal to 1 by rc vs minus vdt. Okay, so 1 divided by rc vs minus v times dt. Now the question is, where is vs? So now we have to make a square wave. So it's a tricky part. We need to make a function here. Let's say diff. Okay, so now I will make a square wave. Okay, so let me make a function here. So I will have a square, let's say square wave. Okay, so now what I will do, so what is inside a square wave? I have two voltages, right? One is, let's say, A1 and another is A2. So that means I have to pass two voltages here. One is A1 and another is A2. Okay, and then let's say that the time when the voltage is at its upper magnitude is the time t on, and the total time period is t. So if total time period is t and the time when the magnitude is at the highest level is t on, so I need to send two times here, t on and t. And then let's say you want to find the voltage at t. Okay, so you want to find the voltage at t, whether is this A1 or A2. So you also have to send the instantaneous time. So let's see what will happen inside this function. Okay, so to understand this is a tricky part. Okay, so let's do it. Okay, so let me make a square wave like this. Okay, I think that's enough. Now this time is equal to total t, then this is also t, this time is also t, and this time is also t. Okay, and now you want to find the voltage at this time t. So we can easily say that at time t the voltage is equal to A1, but we have to code this how I will find that at time t our voltage is A1. So first we need to find how many capital T has been used here, and to find this we will simply divide T by capital T, and we will have, here is 4T, right, 4 capital T's, right, and you also have a small portion here, so you will get 4.1 or 2 something, but we only need 4. And to do this we have to write integer here, and if I write this thing, the decimal part will be omitted, and we will only have this integer part. So let's write this thing. So integer T divided by capital T, and let's say this is equal to the number of capital T, right? So let's say this is n. Okay, so that means this is n, and then I need to find this thing. Okay, so I need to find this r, and how I will find this r? So as this is the remainder, right, if you divide T by capital T, you will have here 4, and at the remainder you will have this 0.2. Where is this 0.2? This 0.2 will appear here as remainder, so this is actually r. Okay, this is actually r, 0.2. So how to find in my code, how to find the remainder in Python code? You have to write T %T, and you will find the remainder here. Okay, and that is in my code 0.2. So r is equal to T % T. You have to simply write shift 5. Okay, so you will have this remainder. Okay, so now what I will do with this thing, let me omit this thing. Okay, so what I have found n is equal to, okay, you know this, n is equal to T by T, and r is T % T. Okay, so now what I will do, listen to me carefully, focus here. Okay, so we know that the time for which the square wave is at the maximum magnitude is T on, right? And from this code it's easily understood that r is less than T on. So if I have to make a condition here, if r is less than T on, then our voltage will be A1, right, the highest voltage. But if you take the time here, that means now r will be greater than T on. So if that means if r is greater than T on, greater than or equal T on, then we will have V is equal to A2, that means the lower voltage. Okay, and finally I need to return this voltage, so return V. Okay, so the code part is done, and now let's see what I will do here. Okay, so let's say our square wave, let's make a square wave here. Let's say upper voltage is 10, lower voltage is -8, upper is 10, lower is -8, and time period is, let's say 4 millisecond, and the time for which the square wave at its maximum magnitude is, let's say 2 millisecond. Okay, so here I have to make BS. So BS is, I make a function square wave, so let's write here square wave, and then I have to send some parameters. First I have to send, so first I have to send A1, so A1 is 10, A2 is -8, and then T on is 2 millisecond, and the total time period is 4 millisecond, and finally the time. Okay, I have to send a time here for which I want to know the voltage, so T. Okay, so what I have done, I make a BS and then I have found a small change in V. So now what I will do, okay, so I have found the small change in V, and now I have to, the initial voltage was V, right? The initial voltage was V, but now the capacitor's voltage is V plus TV, and we need to update this voltage. So let's pick this V plus TV at the V, and now our code is ready. Now the final now finally we need to plot this thing, and to plot this thing we have to import another module here. So let's import matplotlib dot pyplot as plt. Okay, so now I need to plot this thing. So plt dot plot, at the x-axis I have time, but at the y-axis I have the voltage of capacitor, but we haven't make any voltage array. And so to do this, let's make an empty array here, and then inside the for loop let's fill up this voltage. So voltage dot append, then we will fill up this empty array. So finally let's put a grid here, grid true, and then finally plt dot show, and you will see a capacitor's voltage graph here. Okay, let me decrease the time. Let's say, what is RC is 47. Let me decrease this C value, so I will get a clear graph. Okay, so my graph looks like this. But if I make this thing 47 and decrease this time, let's say it's 10 RC. Now let's see what happens. Okay, not 10 RC, 5 RC. Okay, so I have some triangular like shape, right? Okay, whatever, I have obtained a voltage of capacitor, voltage across this capacitor by using this code. So thus you can solve any kind of differential equation with this technique.